Hello and welcome to the channel. In this video, we will study all you need to know about Git. I will begin by defining Git, and then we'll discuss how to get Git. Next, we'll focus on how to use Git. This video will start from scratch, so you don't have to be worried if you're a complete beginner. I will ensure to explain every piece of information in the simplest way possible. So let's start by defining Git. What is Git? Git is simply a distributed open source version control system that is used for making and tracking changes made to files on a computer. So let's note some points at this point of the video. Based on that definition, Git is an open source control system. This means that it's available to the public. We can say that open source in this context is synonymous with the word free. This means that it is free to access. Next, we have used the term version control to define Git. This means that using Git, changes created will be marked and noted as a version so that it can be differentiated from other versions created due to other changes made to the file. So that is where tracking comes in. Let's take an example. While I was in college, I was given an essay to write. Let's say I had 4 weeks to submit the essay, 4 weeks. What happens is, I would edit the essay. For every week I would have a version. Version 1, version 2, version 3, and the final version before submission on week 4. These versions happened as a result of constant improvement, and eventually I had my 4th version. So what happens is, I eventually get to submit the 4th version. But if this were in Git, you're able to revert into the 3rd version or the 2nd version or even the 1st version if you want to, if you had needs for the content of the 1st, 2nd, 3rd. So this is applicable in Git. You're able to switch between versions very easily if, for example, your stakeholder or the client wanted any version. Git also finds its usefulness in software development. Let's say we have a client this way, and this client wants a mobile app developed. They approach a developer, and then this guy begins to work on an application. He develops what we know as the version 1 of the application. Let's call this version 1. And this is deployed to the client. Client does everything with the app and notices that the app has certain problems. The client goes back to the developer and says, I want this app to fix these problems. I want this app to be able to do this and this more things. This requires more features. So the developer goes into work again and develops another application or another version of the same application. Let's call this version 2. And once this is developed, it's deployed to the client. Now the client is happy with this. And then 6 months down the line, this client realizes that there are some needs that he cannot meet with this application. But those needs were met with this application here, the version 1. So he says to the developer, now I want a different version that can do this and this. In fact, it does match the version or the features that I had on the version 1. In that case, the developer will not go ahead to program a new application because he already has this version in Git. What he does is that he reverts back to this version and deploys it back to the customer or the client. So with a system like Git, there should be no problem with reverting to a previous version because every change that is added is tracked and committed, hence can be retrieved. So in a nutshell, that is Git. Now that we understand what Git is, let's talk about how to install Git. Simply go to your browser and type install Git. And you can see that this is the first result that we get in most cases. Once you're on this result, guys, click on where it says downloads Git SCM. Click right there and you find this page. Once you're on this page, choose your OS, Mac OS, Linux, and Windows. If you're on Windows, choose Windows. And then you choose this link or the link that suits your the bit of your PC. Choose the right one and it goes ahead to download. For example, mine is 64. So I'm going to choose 64 and it downloads. As you can see right here in the bottom corner, it has downloaded. Once you're there, guys, you can install it simply by running this application. I'll put a link to this download for Git in the description of the video just so you can find it easily. Once Git has been downloaded and installed on your PC, simply go here to your Windows button for those who are using Windows and for those who are using Mac OS, search for the application, and once you have Git, this is the Git bash terminal we've downloaded. You can open right away. And in a minute, this launches Git bash terminal. When you install Git in this manner, it comes with a terminal. Now, what is a terminal? A terminal is simply an interface which helps you to enter command prompts, and that serves as a means of communication between you and the computer. So in simpler terms, we can term or we can understand a terminal as an interpreter. So that is a terminal. Please note that I'm using Git in this video as it comes with a terminal known as Git bash. However, there are various ways to get Git, such as through Windows PowerShell or command prompts, or if you're on Mac, you can use the terminal that comes with it. Or you can also download third-party terminals such as Hyper, Make-It, Sublime Merge, and there are so many others out there. The first thing that we do once we have the terminal open is to specify our name and email address. This is important because each time we commit something or track something or add anything, we need to make sure that we know who's doing it. To do this, enter the following command: git config -- global user dot name, then in quotes we will include the name of the user. In this case, it is myself, Bruno. And once that's done, guys, click on enter. And at this, you've been able to configure the username. And next thing we do, guys, is to configure the email address for the user. We'll enter the next command. Command is git, very similar, git config -- global user dot email, and then in quotes we'll include the email of the user. In this case, it's going to be one of my emails. I'll say sidcloud44@gmail.com. So once that looks okay, you can enter. And at this, guys, we've been able to configure the user email and the username. And next, we also need to set the default branch name. In this case, we will do the command git config -- global init for initialization, for initialize dot default branch master. So we're configuring the branch name, the default branch name, to be master. As you can see right here, it says master. So once that looks okay, we'll click on enter. And at this, we've been able to configure the default branch name as master. I know we have just introduced a new term, branch, so let me explain. In Git Bash, a branch refers to an independent line of development. So specifying a branch is a way of choosing a directory or where you want the changes and tracking to take place. For every branch in Git, we have 3 environments. The first environment is called the working files. The next one is called the staging environment. The next one is called the repository. Now, every file progresses from the working files to staging and then to repository. These are very important as the commands we'll be running will be moving files through the different environments, from working files to staging and to repository. So let's please take note of that. For those who are new to development and running commands, all these syntaxes here, right here, they're called commands that I'm entering here to interact with the interface here or the interpreter. So guys, these are all commands. Speaking of commands, we'll be using many commands in this video. So let's start by introducing one very important command we need to know, which is the command called clear. My screen so you can see the commands more clearly. The command clear, as you can see right here, this command is very important because it helps to free up your interface. For example, you can see right here that terminal is now clear because of the clear command. It helps to clear your terminal or your interface just so that you can start from the very first line. So that's very, and you want to refer to the very recent command at the top of your screen. That's how you clear your screen by using the command prompt clear. In this video, we'll be using many commands, and if you're unsure what the command means, you can type a function like this. You can type in git config -h, and this tells you what a command is all about. Like this command I entered right now, it tells me what config is all about. You can decide as well to go back down and click on use the command clear, and this clears up your terminal, as you can see. And if you go back and enter git, let's say we want to find out what a command means, like config, you can do that as well by saying config, like I just described to you, config and h. The h here says for help, and then it gives you what config is all about. Okay, there is something I must clarify here. Like I told you earlier, guys, we're using a terminal known as Git Bash. This is our terminal. And because we're using Git Bash terminal, we're able to use bash shell scripting, to give prompts on this terminal. Bash shell scripting, okay? So for those who don't know about bash shell scripting, it's absolutely fine. I'm going to explain every step to you that I'm using here. But just in case you enter, I refer to commands like clear, that's Git commands. Clear is not exactly a Git command, but clear is a bash script. So just so you know that, right? But don't worry, guys, I'm going to explain everything in this video so you will not be lost or confused about it. All right, guys, let's jump back to the video. While you're on the Git Bash terminal, the next thing you want to do is to find out what directory you're currently working on. To do this, guys, type in pwd and click on enter, and it shows you here that I'm working on the C directory. If you're happy with that, guys, you can proceed. However, I want to work in a different directory. And if you're confused about directories, guys, let me tell you one thing. This directory exists on my PC. Let's find out. Go to my files I can see right here on my Windows C drive, there is a directory in users known as Sage C. So, but do I really want to work in Sage C directory? No, I want to work in a different directory known as Bruno. This is the one I want to work in. Okay, so let's go to this directory on the terminal. Right on our terminal, guys, we can change directory by typing cd, then typing the directory name we want to go to. Let's say in this case we want to go to Bruno. We have just typed the command cd Bruno to change our directory to Bruno. So cd stands for change directory to Bruno. Right. So in this case, guys, we go to this change directory to Bruno directory. To find out if this really worked, we can type in the path to working directory pwd to find out what we're on currently. And you can see that gives us Bruno. It says that we are on the Bruno directory. So that's what we want. Let's clear the screen. Okay. Next thing we'll do, guys, is to create some files on our directory. To create files in directory, we can use the command touch project1 or project, let's say, X, and this automatically creates a file called project X. Let's enter another command. Let's create another file, by doing touch project Y and also touch project Z. So we've created 3 files on our directory called Bruno. Let's find out if that has really worked. Let's go to our directory. And we can see right here we have project X, Y, and Z, and this is our directory called Bruno. So that really works. Let's go back to our terminal. Now that we have verified where we are, our directory, and we've been able to create some files in our directory, let's proceed by turning this directory into a repository. To do this, obviously, we need a command. Before we go into the command, let's talk about what a repository really means. A repository is simply a container for a project that is tracked by Git. And this repository may be local or remote. A local repository is located on a person's PC or computer, on the personal computer, while a remote repository is located in the cloud or hosted in the cloud on a server. So that is the difference between a local and a remote repository. A remote repository allows for collaboration between teammates when working on the project, which is obvious because if it's on the cloud, that means many people can access the cloud. But on your PC, you only have access to your PC, one individual. So that's the basic difference. So to convert this directory into a repository, we use the command git init. As we can see, at this command, we have now created our first repository. Next thing we want to do is to find the status of our repository using the following command: git status. When you run that, you can see that this is the state of our repository. It shows you that previously in that folder or in that directory, or repository in this case, these files were in existence and were deleted. And now these are the current files we have here. So these files are all untracked. This command also gives you some details which are basic. For example, it tells you the Git status. It tells you the branch master. This simply means that the branch we're working on is the master branch. It tells you as well all the files that have been deleted and those ones that exist in the files, like I said earlier. And also gives you details on what files have been committed. Here we can see here that we have no changes added and no commits have been made. This is really important, guys. And so don't get confused, guys. We have referred to in some new terms here, like the word commit, for example, and the word master. So master is the name of a branch. It's like the main branch of this repository or this Git bash terminal, master. And we know what the branch is already. Now, the word commit is what I would explain now. Let's talk about commit. The word commit in the context of Git bash simply refers to recording. To commit means to record. It means to record or take a snapshot of the state of the files in the staging environment. So it all means to commit. So I told you earlier that we have three environments in the terminal. We have the working files, we have the staging, and then we also have the repository right here, the repo. So what this does, the commit here, it takes a snapshot of the files, of the file state here in this stage called stage, or this phase called the staging environment. So that is what the commit is all about. The next term I would like to explain is the term untracked. As you can see right here, it says untracked files, and we have project XYZ as untracked files. Now, what does the term untracked in this context really mean? In this context, untracked files simply means that at this point, Git is unable to account for any changes in these files, which are untracked. So how do we track a file? Once again, let's clear our screen to give more space for us. Then let's try to track a file. We know that we have three files we created here, project X, Y, and Z. Now let's track project X, for example. We use the command git add project X. And once you do this, guys, that means project X is now tracked. And let's track another project. Let's track project Y by doing git add project Y. To track project Z, we'll do the same git add project Z. And now we can see that all three projects have now been tracked. And how do we confirm that it's been tracked? We can find out by using the git status command. Let's run that. Git status. This tells us the state of our repository, or rather the state of our directory in this case. Now we can see that our directory here has three files, and these files have all been tracked. Project X, Y, and Z. It also shows you that these files did exist previously, but they have been deleted. So this is what it tells us about our files. Still speaking of tracking files, these files here are being tracked, the three files, project X, Y, and Z. They are also known as staged files because tracking is the process of moving a file from the working files into the staged environment. If you recall, we mentioned earlier that we have three environments: the working files, the staged environment, and the repository. So staging is simply the process of moving the file from the working environment or working files into staging. If for any reason we've staged or tracked one of the files that we have to, we can actually unstage a file by using a simple command. Let's clear our screen. We can use the command git rm dash dash cached, then the project name or the file name, project Z in our case, and enter. At this command, project Z has been unstaged. And how do we confirm this? By using git status to check. This shows you that only 2 files have been staged at this point, leaving project Z untracked because we just unstaged it. So that's how you can unstage or untrack a file that's been tracked. The next thing we'll talk about here is how to ignore a file while tracking so that the tracking doesn't affect the file. Let's say we have a directory of files and there is a particular file. Let's say this file has some confidential information and we don't want this form or this file to be tracked. What we can do is we can apply a function that will ignore this file. But how do we do that? Let's see our command. To explore the ignore function, let's add a file. Let's say the file will be, we'll clear our screen first of all. I would add a file. Let's touch a file. This file will be called, let's say, explore.png. And this file has been added to the working files. Let's have a look. Now that the file has been added into our working directory, let's find the file. Let's say if we list our files, this is the ls function, guys. It means list. And this is bash shell scripting. Okay, so this is explore, and this is the file we just added right now, as you can see. So that's what we want. So this file is in our system. Let's say if we wanted to ignore this file, how do we go about it? Let's say we wanted to ignore the explore.png file. What we can do is to go to our working directory. That's Bruno in stage C. We can go right here and create a new file to be a text file. I will term this file dot git ignore. Let's open this file, and then in the file we can add a comment like ignore all png files. Let's see, all.png files, and then on the next line we can put an asterisk and say .png. Once that's done, we can go to file and save it and close the document. Back in our terminal, guys, what we can do is, at this point, this file has been ignored. So when you type your git status, we should not see this file anymore on our directory. Right, this is for your information. What you can do, guys, if you want to read more about git ignore and how to use the function, you can go to github.com/git ignore. When you go to this link, you're able to access the full details of how to ignore files using the git ignore function. Now we know how to ignore files. Let's talk about tracking. Let's say we wanted to track a file. We've tracked files already. Let's say, I know we unstaged the file at some point. Let's go to git status again. Git status. Git status displays this. You see right here, we have a couple of files here. We're only focused on these files here, X, Y, and Z. But the Z file, as you can see here, the Z file was unstaged at some point. So let's go back and stage this file or track this file. What we can do is to simply do git add project Z. Now this, guys, this project has, or this file has been added. Let's go back to git status and see if it was added. Now we can see that this file, project Z, has been added to the list of files that were tracked or that are being tracked. Let's clear our screen. If, for example, you would like to add all the files in the working files area or environment of your directory, what you can do is to use some commands like git add -a. This would do the job of tracking all the files on the system. You can do this, or you can also do commands such as git add and a dot. This is the same thing as commanding the system or the interface to track all the files in the working environment of your computer. And in our case, all the files have been tracked, and we can verify that by using git status. I know we have more files here which are added at some point in time, but I want us to focus on these three files here, which are the X, Y, and Z. Now that we have studied how to track files, the next thing we need to understand now is how to commit files. Remember that I have briefly introduced the term commit, but once again, this means to record or take a snapshot of the current state of the directory. To commit, we can use the following command. Let's clear our screen. We can use the command git commit m, and we can add some information right here in quotes. Let's say we can say this is the first stage of the project. We can do this and click on enter. There you go. And at this point, we've done a commit. Despite having committed our files, we can still make changes to our files. Now that we have committed successfully, we can call the version that we have produced here as version 1. Our first version, version 1. However, it's possible that we can detect errors in what we did before in this version, and that will result in some changes. We can make those changes in the following way. There are mainly two ways to make changes to files after being committed. The first method is going into our directories. For instance, you can go into our working directory here and effect changes. The next method that we can apply to modify files that have been committed is by going to our terminal, through our terminal. And we'll do this through bash scripting. Using bash scripting, we can VI into any of the project or files. Let's say we want to VI into project X. Now this is bash scripting. VI means we're accessing the files, okay, to make modifications. So let's do this. Click on enter, and we'll click on insert with the button I, and now we're able to modify this file. Let's say we want to put some content in this file. I would put a comment and say we are commenting on this file to update the status of the project. Now we can say and comment. The project has been completed. Let's just keep this simple, okay? And then once that's done, guys, we'll click on we'll select or click rather on the escape button, click on the column button, and then WQ, enter. And then we've been able to make some changes in the file. Now, to see what changes have been made, modifications, we can use the command git diff. With this command, you can see that it shows us that we made some changes. As you can see, the entry we entered has been displayed in the terminal. You can see right here. We are commenting on this file to update the status of the project. The project has been completed. You can see all that here has been written in the file. So that's what git diff helps us do on the terminal. We should observe for some changes. You can see right here that the new entry is highlighted in green, which is very important, so you can easily spot it. Right, so once you're happy with this modification, what you can do is you can go ahead to track the file that's modified. And remember, we are dealing with project X file, as you can see right here. That's the file we're dealing with. So let us go ahead to track this file. As usual, we'll use git add project X and enter. It says here. So let's see the status of this directory. Let's go to git status and see what it looks like. There we go. We still have our projects. We have this here as modified. Project X is modified. So this is exactly what we expected. We can see that because we used the git add command for this file, which is project X, the file has been put back into staging. So if, for example, we want to unstage this file for any reason, we can still use the command git restore stage project X. This will unstage the file, or as we said, move the file back to the staging environment, which, as we know, this will take the file from staging to the working files. And in the working files, it means that Git cannot account for the changes in that file. Remember we said that if a file is in the working files area, what that means is that if you commit the current state of the directory, the file that is in this area, the working files area, will not be included. So that is when you unstage a file, it goes from staging back to the working files. Okay, so because we're not going to be doing this at this point, we're going to be simply keeping the file in the tracked area or the stage area. Let's proceed. So let's clear our screen and try something slightly different. Let's say we want to unstage the file. Let's do git restore state and project X. At this point, the file has been unstaged. Let's do git status to ensure that we have unstaged the file. So we can see here that the file project X has been unstaged or moved back to the working files. If a file is in the working files environment, we can decide to commit the file before or without staging. So I know I told you earlier that we have 3 environments. We have the working files, the staging, and the repository. And we're able to take files from the working files into staging and from there to repository. However, it's possible to take a file from the working files area directly to repository. And this is what we'll do next in this video. Let's go back to our terminal. To commit project X without staging, we'll use the command git commit a-m and then in quotations would write a message. Let's say we can say this is a copy of a modified file and second commit. Okay? Let's do this, and then we can click on the enter button, and we can see that that has been committed. Let's try to view the directory status with the git status command. Git status. So this tells you that the working tree is clean. There's nothing to commit. Now we have introduced a new concept or a new term known as the working tree. So you can see right here in our terminal, it says the working tree is clean. What does this really mean? Our working tree clean. That simply means that the working files area, which is our directory Bruno, is clean. In other words, all the files here have been dealt with or have been committed. That's what it shows here. So that's what we refer to when we say the working tree. It's the working files area of our directory. Usually in Git, when we talk about modifications, this might include either additions to a file or deletions. We've seen how to add to a file, but we can delete as well a file if we don't want the file anymore from the system. How do we delete a file from the system? There are basically two ways to go about this. One way is to go to our Windows C drive, and we go to the right folder, users folder, and find our directory here, Bruno. In this directory, we can decide to delete any of these files. For example, we can delete this file right here by saying, clicking on it and going to delete. It's that simple. So that's one way to delete a file. The next way is through the terminal. Go to the terminal and use the command rm project X, for example. Once you do this, you will remove the project or delete the project of the file from the directory. That's an easy way. Alternatively, you can use the command git rem project X. Sometimes this may not work in a terminal, but go ahead and give it a try and let me know what you find. Let's talk a little bit more about making modifications to files. Generally, files may be classified as tracked and untracked. If you make a change to a tracked file, of course, it can be tracked and noted. But if you make a change to an untracked file, then it's difficult for Git to track or to understand or note this change that's made to the untracked file. In the same vein, if you delete an untracked file, then it cannot be recovered anymore from the system. But if you delete a tracked file, there's a way to recover it in Git. So how do we recover a deleted file if it was tracked previously? Let's go to a terminal. Let's clear our screen and then use the command git restore project X, for example. So this is the command you use to restore a file that was deleted, if only the file was previously tracked or in the staging area. Or if the file has also been committed, you're able to retrieve the file on Git using this command. Let's see an example. Let's say we decide to remove rm project, let's say project Y, for example. Let's go to git status. We can see that we have deleted project Y. Let's see if we can recover the same project because it was committed. So to restore the file, let's use git restore project Y. And let's go to git status to see if it was recovered. You see right here, previously we saw that it was deleted, but now we see that the working files area or the working tree is clean, means that it's been recovered. So that's how you can recover a file that was deleted if only it was staged or committed. Sometimes, after a file has been tracked and committed, we may choose to modify it by changing its name. So how do we change a name of a file on Git? Do that, we can use the function or the command git mv and then the file name. Let's go to a terminal. Now we have all our files committed. Let's say we choose to change the file name of a particular file. Let's choose project Y and we use the command git mv, then we put the old name in quotes. Old name is project Y, and then also in quotes we'll put the new name we want to assume. Let's say we want to say it's project 5. Okay? And we can run this by clicking on the enter button. And you can see at this point that name has been changed. At this point, you can commit the file once again. Let's commit. You can use git commit. And let's put information here saying project Y has been renamed. I click on enter. And at this point here, we've committed the change that we have made to the name or the name of the file, project Y. It's now been renamed to project 5. As you can see right here, the commit here tells us what has been changed. As you can see, rename project Y to project 5. Don't forget that this is the old version and this is the new version of the file. So what Git does is it creates a new version from the old version. But don't forget that you can always revert to the old version of the file if you want to. Now we have been able to make changes to our files and generate different versions with the commit command. If you want to go ahead to view all the commits that you've done so far, you can use the command git log. So let's clear our screen and use the command git log. This command here shows us all the commits that we've made. When we started the command or this video, I told you that we had to enter the name of the user and the email. For every command or commit you make, you're able to see the author name or the username and the email. This tells you who made the command, also who made the commit, and when they made the commit as well. This helps for tracking. So Git is very good at tracking. It also tells you the message which you appended to the commit. As you can see right here, this is my first commit. It says the temperature for boiling our eggs. These are all commit statements that were made at some point in time. So these are all changes that were made. This is for project Y, has been renamed. This is a copy of our modified file. You can see these are all the commits that we made. So that is what the git log shows you. It gives you the tracking details you have made with the commit. And something very important with the Git log is it displays to you the unique identification number of the commits, which you can see right here. For each of them, there's a unique number. This is not the same as this. So that's also very important to note in Git log. Also very important is the branch. We've been working on the branch called master or the main branch. We'll talk about branches later, but we need to note as well that the branch you're working on very, very well matters. In our case, is master, but at some point we'll have to change our branch. Let's keep watching. Before we go into creating more or different branches, if you want to make an abbreviated version of the Git log, you can use the following command. Let's go ahead and clear our screen. Okay. So as usual, we can clear our screen by typing clear, and that clears our screen. But there's something more that we must know about Git log before I continue. And it is, when you type in Git log, okay, it gives you all this information right here. Now, because you're in the log area of Git, let's say that you're not able to type in commands right here. You can see right here, I can type in clear, for example. I can't clear the screen from here. It's not going to work. So to get out of this environment of Git log, all you have to do is to use the button Q. Use Q and it leads you back into the terminal where you can write commands. So if you don't do this, you'll be stuck on the Git log area. Back to our discussion. So if you want to display an abbreviated version of the Git log or the log, you can use this command. So let's clear our screen to have more space to write code, and let's type in git log dash dash one line. Okay. So this is a shorter version of the Git log. As you can see right here, it gives you the same details, but it gives you a simpler version. It's very important. And one thing as well is important to note is that using this Git log online, it doesn't take you into the Git log environment, which is hard to, write code within. So it gives you a display like this, a summary. However, you're still able to write your code here. So, or your commands here. So that is very important. As usual, the commit or the Git log always shows us all the commits, sort of phrases and statements that were made, or the comments we appended to the commits. Now, if for some reason you've realized that you made an error in the message you used to commit, you can also edit that either by making a new commit. For example, if you're not happy with the message, you can do a new commit by doing git commit with the new message, or you can decide to do it in a different way. You can use the following command: git commit -m, and then you can put the modified statement here or file name here. For example, let's say we want to modify this statement here. Project Y has been renamed. Let's say, copy this out. I'll enter it right here. Let's say we want to make it something different. Let's say, want to say renamed. You say has not been renamed. Okay, has been renamed. Let's say has been renamed to day. Okay, let's just add something else, make it different. Then we can do that, and then space dash dash amend. Okay, so once that's done, we can enter, and that has been changed. If we want to verify if this change has taken place, we can go back to command git log dash dash one line. You see that this has been changed. You can see right here, it says here, Project Y has been renamed today. So that's the way you can change the commit statement that you append to a specific commit on Git. And if you ask me, I think it's a quick way to make an amendment. If for some reason you want a more elaborate report on the Git log or history of changes, you can use the following command. Let me just clear our screen. You can use the following command. You can say git log -p. So this gives it a more elaborate sort of report on the Git log history. After viewing this, as usual, you can use the button Q to exit out of this view. So let's use Q. And that brings us back to the terminal where we can write commands. So if you're a first-time user, I understand the commands we have used may be too many for you to remember or understand. So what you can do is to use the help command. As I told you earlier, you can use the command. In this instance for git log, you can say git help log. So that gives you all this information right here. It tells you a description here of the command. It tells you options. It gives you much more information than you can imagine here on how to use that command. So this can come in handy for you if you're a first-time user, and for any user at all. You always want to know more sometimes, or know how to use various the command in various ways. That's how you go about it. So let's talk some more about the Git log. So one of the amazing things about having the commit history is that you can access any of the commits generated earlier. For instance, when we use the command git log --one line, when we use this command, the number code or hashtag before each commit, like this number right here, this hashtag can be used to revert to a previous version of that commit. You can do this the following way. For example, if we were to revert the previous commit of this, we can say, we'll copy this out, go down here and say git reset. Then we can paste the hashtag. So when you do this, guys, you will revert to the earlier version of this commit. And clearly, you shouldn't do this if you don't want to revert to that earlier version. This is just for your knowledge. So let's clear our screen. And let's go right here. And let's go back to git log one line. Sometimes you realize that you want to reorder the way that the commits appear. For example, you can use what we know as rebasing. The rebase command appears like this. You type in git rebase I --root. So this command helps you to reorder the way your git log appears. But since we don't have use for that, it's just for your knowledge. So now let's talk about branches. As we know, we've been working on the master of the main branch for all this project here. But what if we wanted to create another branch? Perhaps you're asking, why would we need to create another branch? Let me show you something. Typically, what happens is, if you're working on the master branch, for example, and you've made your commits, and you happen to spot some errors in the commit that you've made, what happens in the real project is, You don't exactly modify the errors in the master branch. What you do is you create another branch. Let's call that branch a secondary branch. In this branch, the new branch you've created, you can now make the modifications. And if you're happy with the modifications here, you can now merge this branch with this branch. So you can now merge the secondary to or with the master branch, and then you'd have the errors affected or the corrections or the amendment affected. So that's what happens in a typical project. This is very important to note because most times what you find is in projects you have multiple individuals working on the project. Let's say you have five or so we have three developers, okay? Three developers working on this project, developer 1, 2, and 3. What happens is if this guy spots an error or what he thinks is an error, they can decide to create a different branch, secondary branch, okay, and fix the error in this branch, after which they can now request these guys to have a look at this amendment to see if it's okay. Once this guy say it's okay, this guy can now have the go ahead to merge this with the master branch. So that's what you find in a typical project. So before we forget, let me once more remind you of the meaning of a branch. We said earlier, in Git, a branch refers to an independent line of development. So specifying a branch is a way of choosing a directory or where you want to make changes to. To find out the current branch, use the command git branch as we saw. So let's go back to our terminal. You see that the command git branch tells us that we have two branches here, checker and master, but we're working on the master branch. And how do you create a new branch? By simply writing this git branch and then the branch name comes next. For example, you can say branch is test branch. So that's how you create a new branch. You can also do this. Just put in test. That creates you a new branch. But let's click enter and create a test branch. Well, let's say we make a branch called bug fix. So this branch right now is a new branch. Let's see how many branches we have. Initially, we had two branches, the master and checker, and we were on the master before, as you can see the asterisk, master. Let's write git branch. It tells us that now we have three branches, the master, checker, and bug fix, which we just created right now, bug fix. There you go. So we see we are on the master branch. The one we're on is the one that has the asterisk, master branch. But if we want to change branch or branches, we can simply type in git switch, and then the name the new branch comes in. Let's say we want to go to bug fix. Bug fix. It says here switched to branch bug fix. Let's say, what if we type in the name of a branch that does not exist? Let's say we do git switch to test. Okay, it says here invalid reference test. So you cannot switch to a branch that's not been created. So you must first of all create the branch before you switch to the branch. So how do we know that we have actually switched to our new branch? Let's type in git branch. It tells us that we have three branches, yes, but we're now in bug fix. So while we're on the new branch, we can make changes and then modify the changes. I know what you're thinking, but the master branch was the branch that had all the files and all the documents and all the changes. How come we made a new branch and suddenly the branch has content? And let me explain to you how this works in Git. Say we have the main branch, the master branch. And in this branch here, we're working with about 4 files. These files are in this branch and have been committed, for example. And we find an error, let's say in one of the files or one of the commitments that were made or the commits that was made. What we can do is to create another branch. Let's say we create a branch known as the bug fix. In this branch, I know you're probably thinking this branch has no files, so how can we make changes to any file here? What happens is the way Git is designed is that once you create another branch like this, it duplicates. The files are duplicated here. Whatever you did here is duplicated. For example, let's say we have four files that were committed right now in this branch. What happens is because we have a new branch here, a secondary branch, let's say called bugfix. It could be any name at all. It doesn't matter. What happens is that the files are duplicated. So automatically, once you create bugfix would have the same features as available in the main branch. So that's how this works. If you created, let's say, a third branch, that branch would have a duplicate of what is in the master branch. It will have the 4 files or the 4 commits you made in the master branch. So that is exactly how having a branch works or making a branch works. So don't be worried about what files are in what branch and all that. So what happens is the reason you make branches is that you don't want to affect any change in the master branch directly. You want to be able to effect a change here, and then you can evaluate the change and see if the change is okay. And if you're happy with the change, you can then merge this branch with this branch or this branch with the master branch. So what happens normally, like I told you earlier, is let's say in a project, let's say in software development, for example, what happens is when you develop an application in the master branch and it's provisioned or made available is deployed to the stakeholder, okay? What happens here is if, for instance, there is a bug, it's a bug. What happens is a developer can decide to create a different branch and then fix the bug, okay, fix the bug, and then he now shares the same file with other developers, same branch, and says, okay, developer 2 and 3, are you happy with this change here? Does this really fix the bug? And they'll be like, oh yes, this is a good fix. Now we can merge it with the master branch and redeploy to the client. So what happens is when it's okay, this is now merged with the master branch and then deployed to the stakeholder. So that is the purpose of branches, and that's how branches work in Git. Meanwhile, just to clarify, I know I told you that the files here are duplicated here to any new branch created, but what actually happens is even though it's duplicated, any change that is made here, it does not affect this branch unless it has been merged with this branch, the master branch. So let's keep this a little bit tidy and neat. Okay, so what happens, like I said, is if you make any change to bug fix, for example, a different branch created, the change stays inside bug fix and is not affected on master branch until it is merged. It has to be merged first of all before you can see any changes in the master branch. So that's how it works. So now we have made or created the bug fix branch. What we can do is let's go and make modifications in the bug fix branch. Okay. Now we can see that we are in the bug fix branch. As you can see right here, it's also here as well. It has the asterisks. So in bug fix, you can see all the commits that have been made. As you can see right here, this is a duplicate of the commits that were made in the master branch, as you can see. So what we can do is, let's say we want to change something in project X, okay? Let's use the Q button to leave this environment back to the terminal. And then let's say we want to view project X. Using bash shell scripting, we can say vi to project X. So this leads us into this project, and you can see that this is the information that we have right here. Let's say we found out the reason the customer is complaining is because this thing says completed here, but it shouldn't be completed. Okay, let's say is completed, or let's say we wanted to say something else like it's almost completed. Okay, let's add almost here. So what we can do is to click on we can type I for insert and then modify this. Let's go right here and say we want to add a word like almost completed. I'm keeping this very simple, guys, but this can be very complicated when you have to recode it and all that. But let's keep it to modifying just by adding a single word. Basically, we're featuring a modification. That's the important thing. So once we're happy with this, what we can do is to click on escape, click on colon, and click on WQ, and click on enter, and which will lead back into our terminal. Now we're back in our terminal, like you can see, and bugfix has made some changes. Now, once you make a change in a new branch, what you should do is to add that change, okay? Because that change you've made right now, the files are still in the working area. Let's do git add project X, okay? And next we'll commit the change that we have made. Let's do git commit m, and let's put a statement here in this commit to append with it. Let's say we want to say the bug has been fixed. Let's do this and let's use the enter button. There we go. And we can see that this change has been made and committed in the bug fix branch. This is verify that this change has been made. Let's go to git log, okay? Git log and see what it looks like. Right, you can see right here, it says here, the bug has been fixed. I think we did fix or fixed, but it's fine. Let's just stick with this. The bug has been fixed. Okay, it should be fixed. F-I-X-E-D. But let's work with this. Okay, let's work with this. All right. So so what we can do. Okay, let's go back in. Let's use Q to exit here, and we like that it says that. But we want to go back into the file. Okay, let's go back into the file. Let's go back into project X. Okay, this is okay. Let's use colon. Let's use escape first of all, then use colon WQ and go back to terminal. All right, so let's say we're happy with that. Okay, let's leave it at the fix is not fixed. We can now switch to the master branch by doing the command git switch master. That takes us to the master branch. Now let's verify that we're on the master branch by typing in git branch. It shows that we're on the master branch, so that's good. Now we'll merge with the master branch with the command git merge m, and here we can impute, in quotes, we can impute anything at all that we measured. Let's say we want to impute the change that we made. We can say the bug has been fixed. And then we now have to enter the branch that has been merged to the master branch. In this case, we merged bugfix. That's the branch we're merging. So bugfix, and click on the enter button, and this automatically would have merged or has merged the bug fix branch to the master branch. Don't forget that we had the word almost. That's the word that we changed or modified in the bug fix branch in project X. So let's go to the master branch here, which we are on already. We can verify that by doing git branch. Yes, we're actually in the master branch, and now we're here. Let's look into project X. So we're going to use a bash scripting command right now. Let's cat project X and see what we find. So you can see right now, so the cat command, by the way, is just simply displays the content of a file. Okay, so this is a project file right here. Project X is a file. So the cat command in bash scripting simply displays the content of that file, which comes afterwards, which is project X. So here you can see right now, it says here, we're commenting on this. We didn't change this first line here. This first comment was not changed. What was changed was the next comment. The project has been almost completed. So this is the main or the master branch, and this change has been effected on the master branch. So this was done successfully. So this is how you merge a different branch or secondary branch with the master branch. Now that we are sure that the merging was done successfully, what we can do is to delete the branch that we created, which is bug fix. So to delete a branch like bug fix, what we do is run the command git branch -d bug fix, and doing that, the bug fix branch is deleted. So let's see our branches once more to see if it's actually deleted. Let's go to git branch and see how many branches we have. It says here we have checker and master, while previously we had bug fix, checker, and master. So the bug fix has been deleted, obviously. Now let's talk about an aspect that could occur while you're merging, which is known as a merge conflict. And this takes place when you have the master branch and the secondary branch, and you make changes to these simultaneously. After that, you try to merge the both of them. When you try to merge these two, you find that you have what we call a merge conflict. So let's take an example to explain this. Let's go to our terminal. So now we are in our terminal. Let's just find out where we are. Let's find out our directory. We are in Bruno, so that's fine. Let's find out the files that are in Bruno. Let's list the file in Bruno. This is ls for list. Yes, we have project 5, project X, and project Z. Let's find out the content of project X, for example. Let's cat project Z. Now, cat here is simply a function or a command for listing the contents of a file. Okay, so the file here is project X in this case. X, let's make it X. Okay, so now our screen is more legible. Now we have project X and we have cat. Let's cat project X and let's see. Let's enter. I will say that we did make an amendment here. We put almost here. We made a change here, right? So what we will do now is, now we're in the master branch. So what we want to do now is we want to create another branch, and then we want to make changes simultaneously in that branch to the master branch. So let's do that quickly. So what we'll do now, let's check git branch to see what branch we are in. Git branch, and there is checker and there is master. Okay, let's see. Let's create a new branch. Okay, let's do git branch. Let's say new fix. Okay, new fix. So let's do git branch to confirm that that branch has been created. Branch, and that is new fix. Okay, now we have a new branch called new fix, but we're still in the master. So what we'll do now is we'll go to new fix first of all. Let's do git branch new fix, or rather let's do git switch new fix, and now we have switched to the new fix branch. Let's verify that we are in the new fix branch by doing git branch Okay, so once more, we'll just simply zoom into our screen so it can be more legible. Okay, so that's fine now. I think it's better. So now we have the new fix. We're now on the new fix branch. Now that we're on the new fix branch, let's go to project X in this branch. Let's VI into project X. The VI command here is bash scripting, simply like looking up the content of the file by going into the file, right? So that's what we're doing right now. VI into project X. Do that. And we find that this is our X here. We'll press the I button for insert so we can make a change or make changes to this, the components, this file. Let's see here. So let's do almost completed. Let's put another word here. 20, okay? 20. We'll add 20 there, okay? And let's put almost completed. Let's do almost complete, okay? Almost complete without a D. Make it simpler. And then let's click on our escape button, colon, okay? And then we'll click on WQ to exit this this file. And enter, of course. Okay, so we're back to our terminal. Now we're back. What we do is, so let's track the changes in the file project X. So let's do git add project X. Let's do that. And we've been able to track the contents or the changes in project X. Let's now commit what we have in project X. So let's do git commit -m, and let's put something here. Let's put completed to completed was changed in this commit. Okay, was changed this time. Okay, and let's click on enter. And you can see right here that there's been a change here recorded, or tracked, rather committed. Okay, so now we've done this. The next thing we'll do, we'll switch to the main branch or the master branch right now. Let's do git switch. Okay, let's spell it correctly. Switch master. And now we are in the master branch. Let's verify that we're in the master branch by using git branch. And it says that we are actually on the master branch. As you can see right here, it is the one with the asterisk. So that's correct. So just so we can have the commands running at the top of the screen, let us clear our screen. Okay, sorry about that. Let's clear our screen. Okay, now the screen is clear and looking good. Now what we'll do now is to go into project X on the master branch. Okay, let's go to project X. Let us VI into it. Project X. Okay, now we're in there. We'll click on insert I button, and then now we can make changes here. So we can see here almost completed. Let us say we want it to be completed with a double D. This is wrong actually. Okay, it's let's say we do this. Let's say it's almost there. Okay, almost there. Let's say almost finished. Almost finished. Okay, let's do this. And the next thing we'll do is to click on the column button. Then rather we'll click on this wrong. We'll click on the escape button, and then colon, then WQ and enter to exit this screen. And now we're back to our terminal. Now we're back. Let's add the change we just made right now. Let's track it. Let's do git add project X. Okay. And then let us track what we have right now. Let's try. Let's commit it rather. Let's commit it by doing git commit -m. Then let's put something here. Complete changed to finished. Okay, finished, and now quotes to close, and we can enter. So this has committed a change here in the master branch. And now let's do a merge. This is where you can see what happens or how that issue. By the issue, I'm referring to the merge conflict. Let's see how that can happen. Now let's do git merge m, and then let's write something. Okay, let's do finished. Okay, finished, changed, a complete change to finish. Okay, let's do that. Let's do complete change to finish. Okay? Let's enter the branch that we're dealing with. Let's do the name of our branch now. Our branch is called new fix. So new fix. Let's enter. There you go. So this is what we call a merge conflict. You can see right here, auto merging project X conflict. This is a merge conflict. Like I said, it occurs when you have changes occurring simultaneously on the master branch and the secondary branch created. So that's a merge conflict. And I hope it was helpful. When you get this error, what you have to do is to go to your files. When you would go to your files, you will go to your directory, your files, go to the exact file that's affected, which is in our case here is called Project X. Go right there, and then you can open a notepad. You can see that these are the two changes that are happening right now. This is the first one. This is the one from the main branch or the master branch right here. And this is the one from the secondary branch. So what you can do is to choose the one that you want, you want to stay. Let's say we want this one to stay, rather. We can take off this one by deleting everything here. Take off all these comments right here. Delete this, okay? Delete everything about this. Delete the head as well. And delete the new fix. Delete all that, and then you can save this file. You can save it. You can save it and close it. And then you go back. Okay, now we are back to the terminal. After correcting the changes or making the changes in the files, we will simply come to our terminal and enter command git commit -a-m and the text in quotes. Now, just to note something here, we are in a sort of intermediate branch here, or an interim branch, which is the master merging branch right here. This is where this change takes place, or this commit takes place here. And once we run this command right here like this, we are able to resolve the merging conflict. And just so we recall, merging conflicts are a problem, and they occur when you have changes occurring in the master branch and the secondary branch simultaneously. Now that we know how to use Git, let's summarize. We've talked about Git. Git is simply a version control system that is used to create and track changes in files. It does this through using some commands which are important to interact with the interface. In this case, in the video, we use git bash as our terminal. Some commands that we use are git add, git commit, git merge, git log, and so many others. Like we said, we have used git bash, but there are so many other terminals that you could use. When a change is made in Git, what you have is versions. Various versions are created in the process, and all these changes take place in a repository. And this could be in your local repository or in the cloud. The local as in your PC or your laptop. Most times when teams work, they prefer to work in the cloud. This allows collaboration, which is very important in a team setting. One of the most popular cloud repositories is GitHub. Now that we understand Git and how to use it, let's talk about GitHub. GitHub is simply a code hosting platform for collaboration. Recall when I mentioned to you that you can host changes made in Git on either your local computer or on the cloud. A typical example of a cloud host is GitHub. I'm sure you're probably wondering why you should go ahead to host in the cloud when you can host on your local computer. The fact is, if you're working with a team, not everyone would have access to your PC. However, would like to make changes to a project and collaborate. It is in this instance that you would need a cloud host like GitHub. GitHub is currently the most popular cloud repository. Let's see in this video how you can start with GitHub. First thing you have to do is to go to the website GitHub, and you can create an account by signing up, or you can sign in if you have an account already. Since I have an account, I'm going to sign in. Now I'm signed into my account on GitHub, and you can see the interface. This is how it looks. You can see right here, GitHub, you can see this is my profile. You can see right here my profile as well. You can see that there are different tabs here. You can see the pull requests, issues, code spaces, marketplace, explore. So what we'll do now is to create a repository. We can do that by looking to the left corner of our screen. You can see right here, it says create repository. Let's go ahead and click on that. Okay, so we can make this name here. Let's call it project 98. Okay, and then we can describe it by writing anything here. Let's just say this is our first repository. It doesn't matter what you write here, guys. It just to help you describe. Like you see right here, it says optional here. So even if it's not filled out, it's still fine. You make a public or a private repository. We're making a public one here because we want to collaborate with our team members. Okay, so let's go down here. You can add a README file if you want. You can add a git ignore file here. Recall that we talked about git ignore files in Git. So you can do that here if you want. So you can actually add a license as well here, like clicking on this and adding a license, but let's leave it at no license for now and click on create repository. And now our repo is created right here. And now it's created, you can see that right here that it gives you a few lines of code here to automate the process of linking Git to the repository right here. So what we'll do simply is to go back to our Git bash terminal, and we'll just simply go right here and we'll just do something quickly. We can just clear the screen. So, okay, we have it all fresh here, and then we'll simply go back to GitHub terminal. We'll minimize this, back to GitHub, and we'll simply copy this line of code right here. This right here, we'll copy it out, right click, copy, and go back to our terminal, and we'll enter it. Yeah, let's say we enter this and we paste it, and then we click on enter. This command, what it does here is that it links up Git with GitHub, and particularly that repository that we created. Let's click on enter. It says here remote origin already exists. So clearly this is happening because I have already linked it with that repository. Okay, so what we do next is to use the next line of code, which is in GitHub. Go back to GitHub and would enter this line of code right here. It's one that says git branch main. Do that quickly. We'll copy this out. We'll go back to our terminal. I would enter it, paste it, and would run it by clicking enter. And the next thing we do, guys, is to go back to GitHub for the last line of code, which is git push u origin main. Go right here, copy this out, and we will go back to our terminal and enter that once again. and we'll run it. Okay, you can see right here that there's been a push of a repository here on Git into that on GitHub, which is the cloud host. So that is simply what you do to move that into the cloud host, and we've just done that in this video. The next thing we'll do is to go back to GitHub and verify that there's been a push of our code and our files and our committed files and tracked files into GitHub. Let's switch to GitHub. This is GitHub right here, and to verify that, what we'll do is we'll simply go back to our project right here, go right here, and to our repository right here. You can see this is our first repository right here. This is project 98. Let's click right there. So if you observe carefully, this account has not been updated. This is still the command that I entered. Entered all these commands, but I don't still have my codes pushed from GitHub, or rather from Git into GitHub. So the reason this has happened is because I already used a different account, a different GitHub account for push. So what I'll simply do is to switch to the account that I used. Okay, I used a different account. I'm going to go here and sign out and sign into the correct account. Okay, I'm going to sign into the correct account, and here you can see that this is the initial one which I pushed. Okay, before the video I pushed this one and it's been there. So let's go right there to this project and this repository right here. So these are all the projects that we pushed to GitHub. This just happened again, as you can see right here. It's all been updated with our 4 branches right here. And sometimes you find out that you have one branch indicated here. When you have one branch here, here's what you do. If you happen to have only one branch here, here's what you do. You simply go back to your Git and you type in git push -- all. At this command, all your branches will push to GitHub. I've done this already, so this shouldn't be a problem for me. But it says here everything is up to date. You see what I'm saying? Because I already did this before. So once you do this, guys, all your branches will be featured on GitHub, which is very important for you to see what's been updated. Now we're back to GitHub. You can see that our files have been pushed to GitHub. And here are all the files. Here's the file that we updated right here. This one was renamed. This as well was updated here. So if you click right here, let's open this file. You can see that this is what it was before, and this is what it was changed to or modified to. It gives us here the git log record of what we changed, which is very cool. If we go back and we decide to add a file, we can go right here and add a file. What we can do as well is to edit one of the files we have here. Let's say we want to edit this file right here. We can click on the file name, and we can edit right here with this button. Create a new edit, so whatever I want to put here, and then we can go right here, down here to commit our changes. So let's go back. Let's say I'm not happy with the initial changes I made to this project. I can go back to the project right here and make more changes here. And once I'm done with the changes, I can also go back down here and commit the changes here right on GitHub. Let's say we decide to further describe our project. We can go right here and go to the icon, which is right here, and go right here and add more descriptions to our repository. Okay, this is our first repo. Okay, that's what we added here. We can put it here in full by saying this is a first repository. Enter a website URL, a topic right here, and choose the releases if we want to, and we can save changes. So that's how we can describe our projects to make it make sense. If we look above the screen, you can see this here, the issues, pull requests, actions, projects, and all these right here. Let's begin with issues. The issues are where you can, let's say, create something. Let's say you have realized there's an error in one of the files. You want to create, let's say, a bug fix here. You can start to do this here, or like a modification of the file. You can make the issue right here. And let's say This issue is open. You can put the details right here. You can create a new issue right here and say new issue. Write a title here. Let's say this is to update the status of the files of the error in the files. My brain is fried. This makes no sense actually, but just for an example, okay? So you can put here, describe it in details here. And once you're done with the description here, you can decide to submit the issue. Or before you do that, you can decide to assign the issue to someone. Okay, so we can do here, assign to someone. Clearly here is just me right now in this GitHub, no team member, but what you should do is be able to see your team members here to assign them. So what happens is if you have a project repository, you're able to add team members to that. So that helps you assign any such project to them. You can also go ahead to add labels to our project. You can go ahead and do this and add labels here. You can say it's a bug, documentation, duplicate, and all that. You can add all these things depending on the project details. Okay, we can go ahead also to further add details on the project right here if we want to, and a milestone here. If it's a milestone, we can do all that here. This is very important. Okay, if it's an open one, we leave it open, or closed, leave it closed. So it depends on the status of the project at the time. So the good thing about this is that this is a social environment. Once we're happy with the issue, we can close it right here, and that would be an issue submitted. Okay, let's just say this is a bug fix. Okay, and we submit the issue and it becomes a new issue. So here it looks like our Facebook chat or social media chat right here. So what happens is our team members can come here and have a mild discussion on, what this really is, if it's worth discussing, if it's worth fixing or not. So this is where they can do their discussions right here. So this is a very important thing for a team having to collaborate on GitHub. The next thing we'd like to see is a pull request. Let's go back to code and we can see our files back here. Let's say we decide to update our text here. Let's go to text updated here and let's say we want to change something here. Let's say we go ahead to change something here. Let's say we change this. Okay, let's go back one step and click on the file itself so we can update it. And let's click on this button right here to edit what's in here and say here the product has been almost complete. Okay, let's say we don't want that. Let's say we want to put something else. Or will be has been almost complete, but requires no. We can say here, let's delete all this and say but requires the approval of all the managers. For all the managers, let's do this. And then once this change is made, we can cancel the change right here if we don't want to change anymore. Or if we're happy with the change, we can go ahead to commit the change. Okay, let's just say update project X. Let's say let's leave it this way. Let's say um highlighting. Okay, let's say highlighting highlighting the need for managers approval. Okay, let's do that here. I can describe the change in detail here. What we can do is that we can commit directly to the master branch if we want to, which means we're merging this change into the master branch. What that means is that everyone is happy with this change, right? So if that's the case here, we can do that. Else, the next thing we can do is to create a new branch. What this is what we're doing, we're creating a pull request. A pull request is when you're proposing a change that other people have to evaluate before they accept other team members. Okay, so let's say this is a pull request. So let's do here. We can propose a change right here, post changes, and that develops into this page. And what we can do is to describe this request in detail here. And once we're happy with what we describe here, we can create a pull request by clicking on this button. Okay, let's say we say uh, there was an error in the first file because the engineers failed to acknowledge the value of approvals in our organization. So you can write whatever makes sense to you. Okay, so let's do this, and let's click on create a pull request and do that right here. And a pull request will have been created at this, as you can see right here. This is a pull request. Okay. At this point, what normally happens is the teams come here and talk about the merits of the proposed change or the pull request right here. So once that's done here, what happens is they think about if it's not worth considering, they can try to close the pull request right here. What happens is if they're happy with the pull request, right, what they can do is we can go ahead to merge this. Okay, once we merge this, or before we do merge this, we can go ahead here and tie this request to a project right here. If we do this, guys, it's another way to sort of track the pull request if we want to. Let's go ahead and do this, and then okay, and then what we can do is to go right here and merge the pull request. Merging, as we know, is simply accepting the pull request, which means that the changes will be taken into the main or the master branch. Let's do that right away. Let's merge the pull request here and confirm the merge. So once that is done, we should be okay. So see right here, it says here that you are all set. This patch, which is the bug branch, has been safely deleted. Okay, which is what we do normally in Git whenever we have merged, we have merged the changes in the secondary branch. We normally delete the branch, okay, leaving the changes in the master branch. So let's go back to our project and see right here. So here we see right here we have one commit. So let's go here to the issues right here. And this issue, there was an issue here before. This issue here before was the bug that we noted, the fact that there was no approval of the managers featured in the previous text. But here we can see that it has been closed and has disappeared because that has been accepted. So that is very interesting for us. Also, if we note here at the top, we can see right here, it says 0 open, 1 closed. So let's see what's closed. Okay, we can see right here, this is to update the status of the error. This is the file that the branch that we raised as a bug, and it has been accepted. And so it says here that this is closed. As you can see right here, it is closed, right? The status says here is closed because it was accepted. Okay, so that's how we use Git to create a merge and accept the merge and do a pull request. And this is how we do it. Looking at GitHub, there is more. Let's go right to the top. You can see right here, we have actions here. These are the actions where we can actually write codes to control our projects. Here in this on this page, and here we have projects here where you can have a view of your project so far and what it looks like. Okay, so this is what this tab is for. So let's go to Wiki right here. On this page, you're able to create a roadmap for your project. Okay, and here is security. Here you can define how users should report security vulnerabilities to your project, and you can actually tell and get how to get notified when one of your dependencies has a vulnerability. So this is where you do all that security stuff here on this page. And here, go to Insights on this page. It gives you an overview of your pull requests, the pull request and the merge pull request and the closed issues and the new issues that are opened. It gives you like a snapshot of what is happening in your project on the various repositories which are on your GitHub account. And next, onto our settings. On this page, you're able to do a lot of settings on your project and on the account in general. Let's say you want to change your repository visibility. You can do that here. You can actually set here defaults to how you want merges to occur and how you want merges to be squashed and rebases to rebase merges as well. This is where you do all that here to control what happens on the account, default settings of your account. Just a little bit more on the settings here. You can see right here you're able to add moderator options here and collaborators for your project right here. If you decide to add more people, you can do that right here by inviting more collaborators. And if you're happy with all that, you'll be good. And let's go back to the main view of our page, of our repository. And we can see right here that we did make a few changes to our newly created project right here, which is this project right here, 75. So how do we get these changes here to feature on our Git? Because what we did here was like we did some changes here on highlighting the need for manager's approval, but how do we get these changes to be featured on our Git, which is the next thing we'll talk about in this video. So what we can do is to simply go back to our Git. I will type in the command here, which is git fetch, and then click on enter. And what happens is it has now moved all the changes that we made on GitHub into Git. It's like a synchrony that we're creating right here to make sure that all the changes are updated on both sides of the equation. And next we'll do a git merge to merge the changes that we've made. We'll merge them now. It says here already up to date, so that is reassuring. To make things even simpler, instead of typing git fetch at some point and then git merge later, you can decide to use one command here, which is git pull. Okay, git pull, and you enter, and it says here it's already up to date. So git pull simply combines the power or the strength or the effects of git merge and git fetch. So far we've been able to show you exactly how to use Git and GitHub and how you can actually merge, you can add, you can track, you can do all that here. You can pull requests and all that we've explained in this video. I hope it was helpful, guys. I'll add a few details just to help you understand further in the description of the video. I hope it's going to be helpful to you. Please don't forget, guys, to like, share, subscribe to this video, and to the channel rather, and I shall see you in my next video.